Hi guys, I'm Travis Gorsuch, Director of Advanced Materials here at QA1. Today I'm going to give you a tour of our Advanced Composites Lab and show you how we make our carbon fiber drive shafts that are used by champions across the country. First step for our process begins with our engineering department. We've got a great group of composites engineers who take each individual market's specifications and parameters and custom tailor them for the individual designs. And they're able to pull those into our computers and run the simulations to check the critical speed, the torsional stiffness, and the overall torsional strength, as well as many other parameters. We can tailor those to your specific application. That particular design then moves from the engineering department out here to the shop where we will begin the winding process. In this stage of the process, we mix our custom Matrix Resin that has nanosilica with the individual ingredients. We weigh them out and do several QC checks to ensure that the quantities are appropriate. We've engineered our resin to have better compressive strength, minimal water absorption, and better abrasion resistance. These properties were found to be the most important for our high performance market. The step of the winding process requires us to select the fibers, and this is determined by engineering and from looking at your performance criteria. This particular design will use carbon fiber tow. We'll put that in the machine, and our particular winder allows us to very precisely control the angles, the bandwidth, and the tension at which we lay the fiber. This filament winding station is the point at which the dry fiber comes together with our 3M Matrix Resin, which we developed with 3M and their aerospace and transportation group. The resin is applied to the fiber as it's pulled out over the mandrel and wound in place. The important thing to remember about carbon fiber is that the fiber gives you a tremendous amount of strength in one direction. So you can think of it as a rope. You can't push a rope very well, so it's very important that you lay the rope on your part in the right direction and the right angle to optimize your strength and stiffness, as well as minimizing your weight. This is all determined by our engineers before it gets to the lab. The final stage of winding is to wrap the material with the compaction tape. Taping the mandrel helps to provide that uniform wall thickness and superior surface protection. From there, it moves from the winder over to our oven, which is a custom oven that we built in-house, and you could think of it as a very sophisticated home oven. It's got the ability to ramp very precisely, dwell, and ramp back down depending on the cure profile that the material that we're using requires. After the cure profile, the parts are fully cured and ready to be removed from the oven, where they will be extracted. The surface will be finalized and prepped for the bonding. We'll also cut them to the desired length and move on to the next step. We take a sample of every tube and cut a small ring out where we polish and use this for imaging. One thing you don't want is your drive shaft to look like Swiss cheese. With this imaging, we will actually inspect the quality of the tube for the fiber volume, the void content, to ensure that both of those fall within our specs. Now that we've cut our tube to length, we've got our tube prepped and ready for our proprietary 11-step bond process. This is a process that I'm very proud of, and it really makes our product unique, and we've done a lot of work to ensure that the entire assembly works as an assembly, and it's not just a tube with different ends stuffed into it. I can't tell you a lot about this particular process because a lot of it is very confidential, but again, overall, it's helped to reduce the cost of the product so that you're getting the most for your value, as well as ensuring the utmost in strength and performance. Now that the tubes are assembled and cured, they are ready to be torsion tested. This is a very vital part of our process. Not only is it an iterative process that allows us to make improvements to our FEA and ensure our simulations are appropriate and allow us to bring concepts to market quickly, but it also allows us to verify that the quality is where it needs to be. The torsional spring rate is appropriate, as well as the ultimate strength. That is all done here on our torsion tester. Once the part passes that particular test, or those particular tests, then the ends are installed and it is put on our balancer, where we will check the drive shaft assembly for its balance to ensure the run out is appropriate, as well as the overall balance. The balance is very important on the drive shaft to ensure the part performs appropriately at speed and that it is quiet. The last thing you need is a drive shaft that's going to be noisy or have some unwanted vibrations. The final step of the process is packaging. The components are assembled into their box along with the decals and the instructions. Our box is multifunctional. It's meant to be used as a storage device or protection when the components aren't in the race car. And they provide a safe way to ship the components to the end user. Now that you've seen the process, and if you're looking to get a drive shaft, be sure to give us a call or check out our website.